Hi, Algebra 1 students. This is, of course, Mrs. Lee. We are on page M2-146. This is our second day, our day 2 of Double for Fun. And so we're going to be, this is the scenario. So this is our do now, but you need to know the scenario. So basically, Marcus, what he does is he gets like $25 for winning the robotics competition. And so he takes that $25 and he's putting it in the bank. And then he decides that he's going to save some money, right? He's save some money for, what does it say? Robot parts. Well, to buy new material for robot parts, to build a new robot, I should say. And so he's going to put in $10 a week. Okay. He's decided that's what's going to happen, right? And he gets that from tutoring. Okay. And then so Philip here is like, ooh, I'm in that same club. I want some money for my new robot, right? But he gets $40 from mowing the lawn. And every week he's decided he's going to put in $10 as well, right? Can't be outdone by Marcus, right? So he's doing $10 and he gets that $10 from his allowance. Yay, I never grew up with an allowance, so sad, right? So here we have these two, Marcus and Philip, right? Two different bank accounts. And if you notice right here, so we're gonna write that equation down, right? What does that look like? Well, I've noticed that there was a rate, like anytime you see per week or a week or anything like that. So this was $10 per week. So that's going to be our slope. So notice I try to color coordinate these. So this is going to be 10x plus 25. And remember, x is just going to be, well, how many weeks has it been since we first started this, what is it called? This bank account, right? So after week 1, it's 1 times 10, which is 10 plus 25. So it's $35 in the bank account. Got it? All right, so, oh my dear, what just happened here? All right, so then we do the same thing with Philip. And so Philip is 10x, still 10x, same slope, right? Because it's the same amount going in every week, right? But he starts off with a different amount. He starts with 40. So so remember, B is our initial amount, how much he initially starts with. Okay, and then let's see here. We have those two equations, and we do a little bit of comparing the slopes. And if you notice the slopes, yep, just like we said, is the same. So slopes are the same, both m is equal to 10. And the amount of, which means the amount of money deposited weekly. In this case, they decided that they're going to do this weekly. Some people may decide to do it monthly. It depends on the scenario. In this scenario, it's weekly. So how do the y-intercepts compare? And if you notice, the y-intercepts are different. And the y-intercepts are the initial amount they have in the bank account. Okay. So when they first opened it, that's how much they started out with. So we're going to determine this algebraically and graphically. So we're going to use the substitution method. And we looked a little bit into it yesterday. But if you notice right here, so basically if we're saying they're both equal to y, and if they're both equal to y, they both equal each other, right? So in other words, so what I can do is just say, well, if I know that 10x plus 25 is equal to y and 10x plus 40 is equal to y, that means they both must equal to each other. So 10x plus 25 is equal to 10x plus 40, right? It's like saying, let's see here. Oh, hello. There was a bit of a delay. Did you see that? So if I say, John is the same age as Sally. And we also know that Fred is also equal to the same age as Sally. Like they're both the same age as Sally. So then could I say that John and, oh my goodness, I forgot the other person. What was his name? Can't even rewind it. Okay, let's try this one more time. So let's say this is, I'm gonna write, so this is Bob. Here's Sally. Same age. And this is Fred and Sally. And we know that they're both the same age as well. So if Bob knows that he's the same age as Sally, and Fred knows that he's the same age as Sally, and Bob and Fred decide, they meet him like, hey, what's up? How old are you? And they're like, oh, we're both the same age as Sally, which means we both must be equal to each other. Like we're the same age too, yay, right? So these must be equal as well. Do you see what I'm saying? So that's what we're doing here. This is Bob and this is Fred. You know what I mean? So anyway, so we're going to set those. So now we have just one equation with one unknown. We've done these before, right? In the last unit, right? So we're just going to solve it like we normally do. Remember, we think, okay, do we have any parentheses? No. Do we have any like terms to combine on both either side? Nope. They both x and a number, that's fine. And then do we have x's on both sides? Yes, we do. So let's get the x's together, right? And so the only time you should get your x's together, right? So minus 10x minus 10x. And notice the x's on both sides cancel out. Right? So we just get 25 is equal to 40. Well, we know that 25 does not equal 40. It's just not possible, right? That's what we call no solution. That there is no, at no point, there is no x that will give us a solution. And what does that mean? It says Marcus will never have the same amount as Philip at the same time, which makes sense, right? Because if Marcus starts out with $25 and Philip starts out with $40, right? And they're both putting in the same amount every single week. Is Marcus ever going to catch up to Philip? Like, no, can't, right? Like Marcus would have to like add more in there to catch up to Philip, right? Because Philip was already ahead. So what does that look like graphically? So we thought maybe they're going to be parallel lines, right? They're going to be, they start at different places, but they have the same rate. If you look at this, here is Philip's and here's Marcus, right? And if you don't remember how to plot these, here we go. Let me show you how to do that. So if we have, here is Marcus here. Let me just write down his name. So he started at $25. So I always start with the y-intercept. So you start at the $25 right there, y-intercept. And let me see if I can make this, there you go, y-intercept. And then we're gonna, and then it's a slope. So every week he's gonna deposit 10 more. So if we go, it's gonna be $10 up and then 1 week across, right? So that's gonna be at week 1, gonna be at $35. At week 2, it's gonna be $45. At week 3, it's gonna be $55. See how that goes? So he'll always be 10, like some, oh, how many dollars? $15 behind, which makes sense, right? Because Philip started at 40. So Philip is doing the same thing, starts at 40 and goes up 10 to the right 1 week, up 10 to the right 1 week. So it does that consistently all the way through until they decide to stop, right? So as you can see here, they are parallel. So think about what made it parallel. And it makes sense, like, right? So it's like, I used in class, I think, the ages, if is your younger brother ever going to be the same age as you at the same time that you are? Are they going to be like 15 the same time you are, or 16 or 17? I know, like they're never, like, are my kids ever going to catch up to me? Yeah, at the same time. So are they going to be the same age as me at one day? No, because we have different starting points, right? And we aged at the same rate. So every year, you know, it takes one whole year to get to the new year, right? You see what I'm saying? So this is like Philip and Marcus. That's the same dilemma. Marcus will never catch up to Philip. All right. So now we have a different scenario here. We're at the bottom of page 148. So we have Philip, and Tanya wants in on this action, right? She's like, okay, well, I want to do that. And so here's Tanya the fish, and she starts with $40 as well. So just like Philip, she's like, I could do that. And but she's only going to put in $4 per week. Let's see here. So notice right here, our equation for Philip is the same. Y is equal to 10x plus 40. And Tanya's is y is equal to 4x because she's now only doing $4 per week, but she's starting at the same amount, 40. Okay. And so here we go. We graph this one. This one is a little bit harder to graph just because it wasn't exactly. So we just had to go up 4. So 40 plus 4 is 44. 44 plus 4 is 48. 48 plus, we're just adding 4 every time we go to the right one, right? And so we got this. It's definitely less steep because her bank account is not going to have as much. And if you look at the 10th, in the 10th week, right, Philip's going to have $140 and Tanya's going to have $80, which makes sense. I mean, Tanya, it would be less just because, you know, Tanya's not putting in as much, right? So there we go. And does the graph intersect? If so, describe the meaning in terms of the problem situation. So it does intersect at the very beginning at 40, right? And so what does that mean? That means right at the very beginning, they have the same amount. But after week 1, what's going on? That difference is slowly getting bigger and bigger because Philip is paying more into his or depositing more money into his savings account, right? So that is actually the only time they're going to have the same balance, right? Are they ever going to have the same balance again at the same time? Right, because if you notice right here, they get just further and further apart. It's just never going to happen, right? And so here, let's see here. So now, as you hear, it says Philip and Tanya went on a shopping spree over this weekend and spent all their savings except for $40 each. So they're basically back to where they started. And so Philip is still going to be saving $10 a week from his allowance. Now Tanya decides that she's going to deposit $4 on Tuesday and $6 on Saturday. So within that week, it's gonna be $4 and then $6 that she's adding in, right? So Philip claims he is still saving more money each week than Tanya, right? And is it true? And then we had said, well, actually Tanya's saving $10 as well, because 4 plus 6, it's with it. Excuse me, it's still within that same week. So that's still $10 a week. All right, and so we're going to prove this algebraically. So we wrote the exact same thing. Again, Philip's hasn't changed. Tanya's changed a little bit. It's 4 plus 10, like 4 plus 6, right? And then that's going to be times by x plus 40. And if you notice right here, because 4 plus 10 is actually just 4 plus, I keep on saying that 4 plus 6 is actually just 10, right? So y is equal to 10x plus 40. You notice it's the exact same equation, right? So it is the exact same line, if you notice right here. So when will they have the same amount? Every week they'll have the same amount, right? Because they're putting the exact same amount of money, right? And so they will always have the same amount of money if we're looking at per week, okay? Not like in the middle of the week, right? And so just to wrap things up, a few things that we learned today. If there is no solution, okay, that means that they're parallel, right? Which means that they have different intercepts, just like the very first one that we did, right? Where Marcus and Philip, they started off with different amounts, but they put in the same amount every time, right? Which means that different intercepts, but the same slope. Okay, so it's tilted exactly the same amount, right? One solution was the first one with Philip and Tanya, right? Where they started off the same, and then, technically, they are going to intersect at one point. So they will not have same slopes, right? They may or may not have the same y-intercepts though. So I didn't write that down because it could be either way. And then for infinitely many solutions, because they're always going to be this equal to each other, right? It's like this. So 2 lines, it's like matches up. And so they're going to have the same slope and the same y-intercept. Everything is the same, basically the same equation. All right. And so that will be infinitely many solutions. You won't see this one as often just because it's like not an interesting solution. But yeah, but this is what that would look like, right? This is helpful. I'll talk to you later. Bye.